All right, and a lot more of the same, right? So when you look at today's lessons, we're just going to keep kind of extending our knowledge base of linear functions and that pattern recognition, all right? So we're really going to see tables that have a lot more jumps and skips, and we're not going to see that consistent change in x, right? Which is really going to force us to, right, really get down to that unit rate of change and understand how then to manipulate that unit rate of change to fit whatever jump or leap or skip we have in our table. So when you look at the goals for today, our standards for today, right? It's the same three standards that we looked at last time, right? 1.1, 2.1, and 3.1. I can identify a linear function from a table. I can identify the rate of change for a linear function from a table, and I can find those missing values from a table. All right, so let's go ahead and jump right into problem one here. All right, no opener once again because we're kind of just really wanting to kind of hone in and spend a lot of time on these types of problems. All right, to get you familiar with that. So once again, let's look at our rates of change. Notice no skips, or excuse me, I shouldn't say that. Nothing is missing in our table here. All right, that we can see. All right, versus like here we have some missing values. So what we want to do is just work our rates of change and see what's happening. So when I look at this, all right, my x's go up by 4, my y's go up by 12. So my first rate of change is 12 to 4. Now let's look at the next rate of change. Y's go up by 3, x's go up by 1. So that looks different, right? So that's 3 to 1. Now that's my unit rate of change. So right now, I know my unit rate of change is 3 to 1. All right, so anytime the change of x is 1, that's our unit rate of change. Now the question is, that first rate of change was 12 to 4. Does that match 3 to 1? So if we reduce this, all right, 12 to 4 is 3 to 1, right? I can divide 12 by 4, that's 3. 4 divided by 4, that's 1. So it looks like it's the same, all right? Now, it didn't look that way in my table, and that's why we have to reduce and get to that unit rate of change. Let's see what happens on our next one here. All right, so notice 3 to 7, I go up 4 again. Now, it should match if it's linear, right? If I went up 4 for x here, my y's should go up by 12, and they do, right? So I get another 12 to 4. All right. Now let's look at how my y's change here. So I go from 27, all right, to 36. That looks like I go up 9 there. All right. But notice my x's, I go from 7 to 10, I go up 3. So my change, my rate of change is 9 to 3. That looks different than what we've had before. But we knew 12 to 4 reduced to 3 to 1. Now if I look at 9 to 3, once again, I can divide 9 by 3 and 3 by 3, and that gets me to 3 to 1. All right. So we can see that it's remaining constant, even though it looks different in the table. It's that unit rate that really counts as far as constant rate of change. All right, when I go from 36 to 51, I go up 15, but my x's go up 5. So I get 15 to 5 here. So 15 to 5, all right, and that is also 3 to 1. All right, and then once again, I get here, all right, I go up 9, 51 to 60, and then I go up 3 here. So I go 9 to 3. And so notice, even though all these rates of change look different, when we reduce them, when we get them down to that unit rate of change, right, we can see that it's really a constant rate. All right, and then that unit rate is 3 to 1. And that what that tells me is that we are, in fact, working with a linear function. And then our unit rate is a constant of 3 to 1. And our rate of change is a constant of, and then once again, you can write any of these because it means the same thing, right? So 12 to 4, right? 15 to 5, 9 to 3, those all mean 3 to 1, right? They just look a little bit different. All right. So let's take a quick look at problem 2 here. And let's see, once again, notice there's no missing values in my table, so I can go right in and start looking at those rates of change. All right, so notice when I go from 16 to 1, I go down 15. When I go from -4 to -1, I go up 3. So my first rate of change is -15 to 3. Not my unit rate of change, but I can make it look like a unit rate. So -15 divided by 3 is -5 to 1. All right, so let's look at what happens again. So notice here, 1 to -14, I go down 15. -1 to 2, I go up 3. So I see that same rate of change again. Beautiful, right? I know it already reduces. All right, now I go down 15 again, I go up 3. So we're seeing a very similar pattern here. Now notice, now it changes a little bit, right? Because now I go down 20 from -29 to -49. But my x's change. I go 5 to 9, so that's +4. So this looks different than our first three rates of change. All right, and so now negative 20 divided by 4, that also reduces to negative 5 to 1. So we're going to see that we're same unit rate of change. All right, I get from negative 49 to negative 60, I drop another 20, but my x's go up by 4, so I get to another negative 20 over 4. And then I can see that one more time here, I get a negative 20 and a plus 4, so I get that same rate of change every time. Right? So even though these numbers look different, it's really the unit rate that we want to compare. All right, so we can definitely see that this is a linear function. That unit rate is that constant of negative 5 to 1. All right, and we can say that constant of, right? And once again, any of those three would do, right? Because they all mean the same thing. All right, so now hopefully you're getting an idea of like where this unit rate falls in, right, and how it helps us. All right, so now let's look at problem 3 here. So we can see that I'm missing some y values, right? So I'm going to have to be able to use that rate of change if it's linear, right? If it's a constant rate, to go back in and find these missing values. So let's start with the ones we know. So when I go from negative 8 to negative 4, that's a plus 4. 52 to 36, I go down 16. All right, down 16. So my first rate of change I can see is negative 16 to 4. And once again, let's look at that unit rate. If I reduce that, I can divide both of those by 4, and I get negative 4 to 1. All right, so 16 divided by 4 is negative 4. 4 divided by 4 is 1. All right, now let's look at this. Now I have this big jump right here. So I'm going to go from 36 to 4. When I go from 36 to 4, I go down 32. But then I'm also going to go from negative 4 to 4. And so I go up 8 for my change in x. All right, so that looks different than our first rate of change, right? So I take a look here, negative 32 to 8, that looks different. But the question is, does it give me the same unit rate? All right, so negative 32 to 8, once again, I can divide both of those by 8, and that gives me negative 4 to 1 again. So awesome, right? Let's look at one more here. All right, and I go from 4 to negative 20. All right, I go down 24. But my x's, I'm going from 4 to 10. So 4 to 10 for that jump, and so that's up 6 right there. And so once again, it looks different to start with. So negative 24 to 6. All right. But if I reduce that, right, once again, I can divide the numerator 24 and the denominator 6 by 6, and that gives me that same unit rate of change, negative 4 to 1. Now, this is why it's so important that we want you doing this kind of work, right? Don't try to hold it all in your head. Write it down. Make it concrete for yourself so you can see those numbers, all right? Because what I can see now is even though these three rates of change all look different, once I reduce them, I get the same unit rate. So my unit rate is negative 4 to 1. Right? And then we know that's a constant, all right, which tells me that it's a linear function. So now here's the question. How do I use that unit rate of change, all right, to find my missing value? So now let's go back in and start looking at it kind of a little bit cell to cell here. And this is how we do this. Now notice I go from negative 4 to negative 1. So this is an increase of 3. So now I have to figure out, okay, how does y change? And once again, it goes back to this unit rate, negative 4 to 1. So remember, this is the change in y over the change in x. Now, I want my change in x to be 3. So to go from 1 to 3, I'm going to have to multiply by 3. And then whatever I do to the denominator, I also have to do to the numerator. So I need to multiply it by 3. And so negative 4 times 3 is negative 12. Now we're really going in reverse of what we did here. So notice we took our ratio, all right, our rate of change, and we divided to get to our unit rate. So what we're doing now is the opposite, to where I'm going to multiply by a number to get to an equivalent rate of change. And notice if I did negative 12 divided by 3, I would get negative 4 to 1. So that tells me that when x goes up by 3, y has to go down by 12. And so 36 minus 12, that is 24. Now, I should be able to find my next rate of change now, right? Because now nothing's missing between these two cells. And it should, if everything's working out right, give me the same unit rate. So -4 to 5, notice that goes up 5. 24 to 4, I go down 20. All right, well, notice -20 to 5. All right, if I reduce that, I get -4 to 1. So my work is holding. Now notice I go from 4 to 8. I go up 4 in terms of x's. Well, that's great because I already have one change of 4. So I know every time x changes by 4, y has to change by -16. So that's almost a little bit of a freebie there because we've already figured that out from our earlier work in the table. Once again, another point of writing down your work, right? Okay, so now 4 minus 16 is -12. Now let's check our next rate of change because now we don't have anything missing. So 8 to 10 is 2. -12, -20 is -8. So -8 over 2, that is also -4 to 1. So it's holding up, right? Okay, now I go from 10 to 20. So I go up 10. So now I got to figure out, okay, what do I need to do here? So once again, I'm going to go back to this -4 to 1, right? And I want this to be a 10. So I would do 1 times 10. So now I would do the same thing in the numerator. So I do -4 times 10, and that's -40. All right, so then I would subtract 40 here, and I would get to -60. All right, and then I can see that I have that constant rate of change. And once again, it's a constant of, right? And then it's whatever those you want to plug in there, right? All right, so let's take a look at one more, and then we'll go from there, and then we'll wrap things up today. All right, so let's look at number 4 here. All right, so let's look at this first table. All right, okay, right here, number 4 on the bottom left. We have a lot of stuff missing in the middle, but we have a couple pieces at the beginning and the end to look at to help us with our rates of change. So let's look at this first one. So notice I go down 12 here, right? And I go up 3 here. All right, so we saw that a little bit above here, right? So this is -12 to 3. All right, and so if I reduce that to find my unit rate, I get -4 to 1. Well, let's go down here and see what happens, all right, when we're working down here. All right, so 40 to 4, I go down 36. And at 15 to 24, I go up 9. So it definitely looks different, right? But once again, if I write this out, -36 to 9, and then I reduce that, notice I can divide both of those numbers by 9, and that gets me down to that same unit rate of -4 to 1. So once again, we can see that we have that constant unit rate, which is what we want, right? Which tells us it's linear. And now I can just adjust that unit rate to find our next 4 pieces here. All right, now the first one's a little bit easy because notice I go from -2 to 1, I go up 3. Well, I just figured out that rate of change right here, right? So if x increases by 3, y has to decrease by 12. So I'm going to subtract 12 here. All right, and then that gets me down to 96. But notice this time, now x goes up by 4. All right, I don't have a +4 yet, right? So this is, once again, I'm going to convert my unit rate of change, right? So I need this to be a 4 in the denominator. So I would do 1 times 4, that's 4. And so I would do -4 times 4 as well. And that tells me that, okay, if x goes up by 4, y has to go down by 16. So I'm going to subtract 16. So 96 minus 16 is 80. Now, once again, I look out a little bit because now 5 to 8 is a +3. Well, I know every time x goes up by 3, y has to go down by 12. And that gives me to 68. All right, so notice how writing all this information is going to help you because you can go back and pull from what you've done earlier. So let's do 8 to 10 is +2. I don't have any +2s yet. So once again, I got to go back to my unit rate of change, and I got to convert this to get a 2 in the denominator. So 1 times 2 would be 2. So now I multiply that numerator by 2, and that gives me -8. All right, so I'm going to subtract 8 here. 68 minus 8 is 60. Now, I should be able to find my last rate of change here, and hopefully it gives me that constant of -4 to 1 once I simplify. So this is down 20, 60 to 40. 10 to 15 is +5. And so when I do -20 to 5, it does look different than everything else I've done. But if I reduce that, notice I get that -4 to 1. All right, and that means that we have a constant of, and any of those numbers up here would work, right? So -20 to 5, right? Whatever you would like. All right, so once again, working with those same ideas, right? So very, very important, okay? Don't cut corners. Do the work. Write things down. All right, write things down and then work on this conversion, right? So moving that unit rate, all right, to what you need to find those missing values in the table. All right, we'll continue working on this tomorrow in class. I will see you then.